Hola, sexto grado. Today we are talking about powers, and powers are important because numerically they are super powerful. We looked at I Dream of Djinni, and Djinni gave Kate two options. She could either choose one magic coin, and that one coin would turn into two coins on the first day. I missed that important detail. Senora Smith found it. It's so important to be detail oriented that it begins on the first day. That coin will split into two. On each successive day, the amount of coins will double. So each single coin will turn into two coins for a total of 28 days. So would Kate be better off with that option, or would she be better off just to get 500,000 gold coins right then and there? Well, we talked about in class, and one of the things we looked at was something like this, where we actually draw this out. So here's we'll call it day zero, when there's no time that's passed. There's one gold coin. So that looks like one. All right. And then during that same day, that day one, that coin splits into two coins. So we had one coin multiplied by two, and we end up with two. Then day two, each of those two coins are going to turn into two coins. So we have what the total we had from yesterday, which was 1 times 2, and that is going to double. So we'll multiply that by a factor of 2 again. And we could calculate that, evaluate that expression to find the total number of coins, which would be 4. And now these 4 coins are all going to duplicate. So on day 3, we have the same number of coins we had yesterday, which was represented by 1 times 2 times 2 times 2 up here. And then we're going to multiply that by 2 again because it's going to double. We're going to end up with 8 coins. So this is a little bit laborious. It could take quite a bit of paper and quite a bit of time to draw this all out. So can we look for patterns to see how we could do this a little bit more quickly? Notice what the factors are in each of these expressions. What are the factors we're using? It looks like we're using a factor of 2. So it looks like 2 is the factor we're using. We're also using 1, but the identity property of multiplication lets us know that anything multiplied by 1 is equal to itself. So we don't really need to worry about that 1. We have 2 times 2 times 2, 2 times 2, 2, and then we don't have anything here to multiply by 1. We're just going to say, in this one, we're going to go ahead and multiply, and we're going to say, since 2 has been our common factor, we're going to put a 2 in there. How many times have we used 2 as a factor in this expression? Well, it was 0 times. 2 to the power of 0 is equal to 1. Any number raised to the power of 0 is equal to 1. So we still end up with 1 right here. And here we have 2 is used as a power, is used as a factor 1 time. So we have 2 to the power of 1. Down here, we have 2 is used as a factor, and we see it appears twice. So it's used as a factor 2 times. And in day 3, we see that we have 2 used as a factor 3 times. Based on that pattern, can you predict what we would see on the 28th day, how many coins there would be? I know you watched the resolution video, so I know you know. Just in case you didn't watch that resolution video, we had 1 coin, and that coin is going to be increased by a factor of 2. I didn't want that color. I wanted this color. It's going to be increased by a factor of 2 every day for 28 days. So a factor of 2 will be used 28 times. And that will give us a grand total of 200, oops, lost my calculator, 268,435,435 56 gold coins, significantly more than 500,000 gold coins. This is definitely, she definitely wants that magic coin. Now, what happens if Djinni had said that that coin would triple each day? Well, let's look. If it triples, we'll say day 0, nothing happens. So she has 1 coin. How many times is, with that 1 coin, how many times are we using 3 as a factor? Looks like 0 times. So we're using 3 as a factor 0 times, and 3 to the power of 0 is equal to how many? Yes, it's equal to 1. Now, on that day 1, we're going to multiply that coin by a factor of 3. 3 is used as a factor, it looks like 1 time. 3 to the power of 1 is equal to 3. And 3 times 1 is 3. So 3 gold coins on that first day. On the second day, looks like we have 3 used as a factor 2 times. And 3 times 3 times 1 is equal to 9. And we could continue on in that fashion. I'm not going to fill that out because I think you guys can do that. But on day 28, do you agree that if we follow this pattern, we'd have 3 to the power of 3, 3 raised to the power of 4, 3 raised to the power of 5, 3 raised to the power of 6, ... On to the 28th day, 3 raised to the power of 28. And how much would that be? How many more gold coins would she get if they were raised, if they increased by a factor of 3 each time? I'm going to let you guys use the calculators and figure that out. All right, something else important that I wanted to talk to you about is a little bit of vocabulary. This should go into your math notebook. This should definitely go into your math notebook. This is a power, and a power is composed of a base and an exponent. 2 is the base. It tells us what factor we're using. And then the exponent tells us how many times that factor is going to be used, or how many times the base is going to be used as a factor. That's very important. And why? Why are these exponents important? Not really. Genies don't exist, at least I don't think. I've been rubbing my lamps, but nothing's happened, so no gold coins for me. But in things like mitosis, where we have cell division and it grows at an exponential rate, we've talked a lot about lately in the news, you've heard about the flattening the curve, and it's because that virus spreads at an exponential rate. So we see huge growth. I hope this, guys, helps you. I hope this video has helped you to understand exponents a little bit better. I hope you have a great rest of your day, and we will see you soon.